Hi, this is Dr. Pete. So, right now I'd like to go over some calculations that are very important. So, we're going to go through something called alligation and when you can use this equation, C1 V1 equals C2 V2. Now, when you can use this one, it can be easy because it's just less steps that you have to follow. But you'll have to know when you can use it. So if you have three variables, if you have two concentrations and one volume, or two volumes and one concentration, you can find the missing variable. Okay, with this one. Alligation, on the other hand, if you have three different concentrations, you have to figure out different volumes, then this would be more appropriate, the alligation one. So alligation in this equation are basically when you have an active ingredient and the same active ingredient, and you have um, one with lower concentration, one with higher concentration. You mix them together and you get a concentration between the high and the low. So if you have a 10% and you have a 5% solution cream and you mix them together, you're going to get a different concentration. Sometimes the prescription will call for a certain concentration, mixing two different things together, and this is how you find it. Okay, so let me see here. Get back to the page. Okay. So and also let me just, the best way to learn it is through examples. So the first example is going to be ammoniated mercury ointment is available in 10% and 3%. A technician needs to prepare 450 grams of a 5% ointment. How many grams of each of the 10% and 3% ointment will be needed? And if you, whenever you want, feel free to stop the video and try to work it out and see if you can do it, and then you can always turn it back on and I'll give the solution. All right, so the first thing that you want to do is, okay, so you look at the let me see, you see here, there's a 10% and a 3%. Okay, so we put the 10% up here at the top because it's a higher strength. You put the 3% down here because it's the lower strength. And then you put the final percentage. Let's see, how many grams of each of the 10% and 3% ointment will be needed. And you need 5%. So the 5% goes in the middle. Now you subtract these. So the difference between 3 and 5 is 2. The difference between 10 and 5 is 2. I'm sorry, it's 5. And then the total is 7. So that means that there's 2 parts of 10%, 5 parts of 3%, 7 parts of 5%. Okay? So if you want to find the if you want to find out the 10%, you do 2 over 7, which is the total here of parts, and then you just multiply it by 450 grams, and then that would be 129 grams. And then the 3%, it would be 5 because there's 5 parts of 3%. So it's 5 over the total times 450, and that's 329 grams. 321 grams. So if you mixed 129 grams of the 10% with 321 grams of the 3%, then you get the 450 grams of the 5%. And I'm going to show you something that's going to be very useful in terms of this. If I knew, for example, if I knew that that there was, I don't know, let's just say 200 grams of 10%, but I don't know how many grams. So I know that I'm going to add certain amount of this X to 200 grams, let's just say. Then you can use this as a ratio. Then you would just say 2 over 200 equals 5 over X. And then you can figure out X, and then you can figure out what's in here. Okay? All right, let's go to the next one. Okay. How many mils of each of a 20% stock solution and a 30% stock solution will a technician need to make 500 mils of a 28% solution. Okay, and if you feel like you know the answer to this question, you can always stop the video and then try to work it out and then turn the video back on. So, so there's a 20% stock solution and a 30% stock solution. So we put the higher strength on the top, lower strength on the bottom. Okay, and then you just the final is 28%. Okay, so let me see. There's the difference. Then you just do the difference. 30 and 28. Difference is 2. 20 and 28. The difference is 8. Okay, so now we look at this and we say, okay, first of all, can we do C1 V1 equals C2 V2? Well, that would be difficult to do because we have 3 different concentrations, and this is just one concentration there, one concentration there. So if you have 3 different concentrations you have to figure out, then it's easier to do it this way. So we have 2 and 8, and that means that the total parts is 8 plus 2 is 10. That means that there's 8 parts of the 30%, and you mix it with 2 parts of the 20%, and then you get 10 parts of the 28%. Okay, so we know that total parts are 10. So we do this ratio where we do 8. If you want 30%, you want to find 30%. So hold on, let me put this here. So let's say we want 30%. How much is 30% do we use? Well, there is 8 parts over the total parts, which is 10. And then the total quantity is 500 mils. So we just multiply by 500 mils, and that gives us 400 mils. Now, if you want the 20%, that would be this. Since it's 2 parts of 20%, you just do 2 over 10, and then multiply by 500 mils, and now you get 100 mils. And you can always, if you add 400 plus 100, you get 500, and it checks out. It's 500 mils. So we have, if we add 400 mils to a 400 mils of 30% to 100 mils of the 20%, then you get 500 mils of the 28%. Okay, so it's okay, pretty simple. All right, let's go to the next one. Okay. An order for 6 liters of 0.9% sodium chloride. Solution is to be prepared from 23.4% concentrated sodium chloride solution and sterile water for injection. How many milliliters of each will be used. Okay. Okay, so for this one, let's see if we can use, hold on. Okay, let's see if we can use the equation C1 V1 equals C2 V2. So we have, how many percentages do we need to find? There's 0.9, which is a total, and then there's 23.4, so there's just two, and there's one volume. So it looks like we have perfect perfect numbers of variables that we can use. So let's just see how this would work. Okay, so for C1, let's see, fine, it's 23.4% of sodium chloride, and let me see, we prepared from 23.4, so it's V1. And then C2 would be 0.9% in 6 liters. Now we could put in here 6 liters, or we could do 6,000 milliliters. So if you remember, 1 liter equals 1,000 milliliters. Okay, so I could put 6,000. I'll just do that. I think it will be easier just to do 6,000 milliliters instead of 6 liters. It's the same thing. Okay, so now we just solve for V1. Okay, so V1 equals 231 milliliters. Okay, so what that means is we know that V1, so you look at the concentration right next to the V1, and we see 23.4%. So what that means is percent. So V1 is 231 mils. So it's 231 mils of the 23.4%. So we're adding this much of sodium chloride, right? And this much sodium chloride, this percentage, that's how much volume there is. So there's this much of this concentration of sodium chloride, of 0.9% sodium chloride. Okay, so just look at right next to the V that we figured out, and it'll tell you what that means. So so it's 231 mils of the sodium chloride, okay, the concentrated sodium chloride that we're using, okay? And then if you want to figure out how much water there is, then we know that, so that would be V2. So so that would be equal 6,000 mils minus 231 mils, and that gives you 5769 mils of water. Now let's use the other method. Let's use the alligation method. That makes sense. So if I have the top part is the 23.4%. The bottom part, so since it's water we're talking about, you're mixing with water, water doesn't have a concentration. You just say zero. Whenever it's water, you just say zero. So then we want the final to be 0.9%. Okay, so then this would be, let's see, 22.5 parts, and then this would be 0.9 because you do the difference. Okay, zero. The difference between 0 and 0.9 is 0.9. 23.4 minus 0.9 is 22.5, and the total is 23.4. So that means that 0.9 parts of the sodium chloride plus 22.5 parts of the water equals 23.4 parts of the 0.9%. Okay, 0.9% is normal saline sodium chloride. Okay, now if you want to check the work that we did above, so the sodium chloride, the 23.4%, all we do is we say 0.9 over 23.4, and then you multiply that by the 6,000 mils, because it's a total quantity that you multiplied by, and then you would get 231 mils. If you want the water, you know what? Let me put this here so I can. Okay, the water, you just say 22.5 over 23.4, and multiply by 6,000, and that is 5769 mils of water. So whether we do the C1V1 equals C2V2, right? Or whether we do the alligation method this way, you're going to get the same answer. 5769 mils of water, and then, or 231 mils of sodium chloride. Okay, let's go to the next one. Okay. Okay, technician is to prepare 250 mils of a 40% solution from a 60% stock solution and purified water. And purified water. How many milliliters of each are needed? Okay, so let's see now. Can we do C1 V1 equals C2 V2? Well, let's see now. How many variables? How many? Let's see here. We have 250 mils. Okay. We have a 40% and a 60%. So that's two concentrations. Perfect. How many milliliters? Okay, so we have two concentrations and we have one volume. So let's see what happens. We have, so C1 is, okay, so we have 60% stock solution. So 60%, okay. And then we have V1. We don't know how much of that. And then C2 is, let's see, and 40% solution, so 40%. And V2 is, let me see, 250 mils. 250 mils of a 40% solution. So, okay, so we have 60% and we don't know how much of that there is. So we're going to find out how much there is. And we have 40%, the final amount is 40%, 250 mils of 40%. Okay, so those are together, 250 mils of 40%. We don't know how much of the 60% there is, so we're going to find out. Okay, so V1 equals, if you do 40 times 250 divided by 60, so that would be V1 equals 40 times 250 divided by 60, and that will equal 167 milliliters. So that's, okay, so V1 is the amount of 60% stock solution. So what this means, whenever you see the V and it's next to the concentration, this pertains to this. So V1, which we know is 167 mils, is the stock solution of 60%. Okay, it's 60% stock solution. Now, if we want the V2, that which is the amount of water, then we do V2 equals 250 mils minus 167, and that gives you 83 mils of water. Okay, so you get 100. You use 167 mils of the 60% stock solution with 83 mils of water, and that'll give you 250 mils of a 40% solution. So we can always check our work. We can use the alligation method. We already know that water is 0. We know that 60% is the higher percentage that we're using. Okay, and then and we want the final to be 40%. Okay, you know what? Let me do it this way so we don't get confused here. Okay, so and then we do the difference. The difference between 0 and 40% is 40. The difference between 60 and 40 is 20. So that's 40 parts of the 60%, 20 parts of the 0%, and then 60 would be the total parts. So it's 60 parts of the 40%. Okay? So if we want to figure out how much of the 60%, we just say 40 over 60, and you multiply by 250, because that's the total volume, and that gives us 167 mils. And then if you want the water, you just say, and then 0, which is the water, equals 20 over 60 multiplied by 250, and that gives us 83 mils of water. So it's the same numbers. We get the same numbers on both of these. C1 V1 equals C2 V2. We could do that, or we could do the alligation problems here. Okay, so this 60%, so 250 mils of the 60%, well, to get 40%, to get 250 mils of 40%, you mix the 60%, you mix 167 mils of 60%, and then you mix 83 mils of water, and then you get the 250 mils of the 40%. Okay? All right, let's go to another one. A liter of 1/3 normal saline. Remember, normal saline is 0.9%. Okay, so 0.9. Actually, it's one. Let's do one. I'm sorry, let's do 1/3. So if it's 0.9 normal saline, then 0.9 divided by 3 would be that. Is to be prepared from 0.9% concentrated sodium chloride solution in still water for injection. How many milliliters of each are to be used? Are to be used. Okay. So the first thing we do is, let me see here. So we know that, let me see, okay, so let's do the alligation method first, see what's going on with that. So we know that there's, let me see, so we have okay, so a liter of that is to be prepared. That means this would be the final solution because that's going to be prepared. So that's going to be 0.9 divided by 3, which would be 0.3%. That'll be in the middle. Okay. Now, let's look at the bottom. So we know that there's water. So water, whenever there's water, that's 0. Then the top is going to be 31%, right? So we prepared from point number. So what for injection? Let me see. Oh, 0.9. So that would be 0.9 would be up here because it's okay. So at 0.9%. So we know that this is prepared from okay. So water and 0.9%. Okay, and then the difference between 0 and 0.3% is 0.3. The difference between 0.9 and 0.3 is 0.6. And the total is 0.9. Okay, so we know that 0.3 parts of the 0.9%, and you add, and there's 0.6 parts of water, and the total parts is 0.9. Okay, 0.9 parts is total parts, which is the parts of the 0.3%. Okay, so if we have 0.9%, so this is 0.9%, we want to know how much of 0.9%. So that's 0.9. I'm sorry, the 0.9% is 0.3 over the total, which is 0.9. And then there's a liter. I missed that for a second. A liter. So that's 1,000 milliliters. And so the total would be 333 milliliters. And then water. So this is the 0.9%. And water would be 0.6 over the total, which is 0.9. and then 1,000 milliliters, and that will equal 667 milliliters. If you add 667 plus 333, you get 1,000 milliliters or 1 liter. 1 liter is 1,000 milliliters. Okay, and let's see, can we do, hold on, let me just see here. Can we do C1 V1 equals C2 V2? Well, let's see here. We have a liter of, okay, so that would be 1 liter. And the first concentration would be of so that'd be 0.3% equals 0.9. Okay, and then 0.9 and then V2. All right, and then just get my trusty calculator out here, and it's 0.3 divided by 0.9, 0.3. Okay, so that would be, okay, so the total concentration, 1 liter of that, and that's, so that would be, okay, let me start here. The total concentration is 0.9. And that gives you the exact amount. So that'll give you V1, or I'm sorry, V2 equals 333 milliliters. Okay, so it gives you this, it works. So C1V1 equals C2V2 also works. Okay, so that'll give you, if you look at V2 right here, that gives you the volume of the 0.9%, and that's right here, 0.9%. And so 0.9% is 333 milliliters. Okay, so it does work. And then if you want V1, you just take the total quantity and you subtract 333 from that, and you should get 667. Okay? Okay, so stock solution, oops, of 27% and 31% are available in the pharmacy. How many milliliters of each stock solution are needed to prepare 2 liters of a 29% solution? Okay, so the first thing we do is Okay. So we're going to look at stock solution of 27%. Okay, so first thing we do is we know that the top part is 31% because there's two concentrations, 27%, 31% available in the pharmacy. So we say 31% is the top part, 27% is the bottom part. Okay, and then the final concentration is 29%. So the difference between 31 and 29 is 2. The difference between 27 and 29, wait, 29, yeah, is also 2. The total is 4. So that's 2 parts of 31%, 2 parts of 27%. So you're mixing 2 parts of 31%, you're mixing 2 parts of 27%, and you get the final is 4 parts of 29%. Okay? So if we okay, so if we want to find out how much of 31% and how much of 27%, we just say, okay, so for 31%, we know that 2 parts over total parts times so there's 2 liters. We know that 1 liter is 1,000 milliliters. So 2 liters is 2,000 milliliters. Or yeah, 2,000 milliliters. And the total would be 1,000 milliliters or 1 liter. And if you want the 27%, then you say 2, okay, 31%. Then it's also 2 over 4, 2,000 milliliters equals 1,000 mils or 1 liter. So in other words, you're going to have equal amounts. You take 1,000 milliliters or 1 liter of the 31%, you mix it with 1,000 mils or 1 liter of the 27%, and then you'll get the total quantity, 2 liters of the 29%. And you can mix, if you add 1,000 mils plus 1,000 mils, you get 2 liters. Okay? So you add these together and you get that. Now, let's find out if C1 V1 equals C2 V2 works. So we have stock solution of, actually, it won't work because we have 27%, we have 31%, we have 29%. We only have room for 2 concentrations, not 3. Okay, so we would have no place to put that, and it would be too difficult to figure that one out. So just if you have too many concentrations, too many volumes, if it doesn't fit this equation, then it's just easier to remember that alligation is easier. It's actually very easy to do alligation. Both of these are easy. Alligation, you really can't go wrong with that. This equation is pretty simple, but you have to know when to use it. Okay. From 2 stock solutions, 18% and 42%, you are to prepare 1.5 liter of a 34% solution. How many milliliters of each of the stock solutions do you need? Okay. So let's go through this again. And by the way, again, you can always stop the recording, pause it, and then try to do it yourself, and then turn it back on, and then watch me do the solution. Okay. So there's two stock solutions. We know there's one that's 18%, and the top one, which is the higher concentration, is 42%. And we know that the final is 1.5 liters of a 34%. So it's 34%. Okay, so the difference between 42 and 34 is 8. Difference between 18 and 34 is 16. So if you want to find the 42%, oh wait, first of all, when you add these up, you get 24. So it's 16 parts of the 42%, and there's 8 parts of the 18%, and there's 24 total parts of the 34%. So that would be 16 over 24, 1.5 liter equals 1 liter or 1,000 milliliters. And then if you want the 18%, that's 8 over 24 multiply by 1.5 liters, and that is equal to 0.5 liters or 500 milliliters. So if we add this and this, you get this. 1 liter plus 0.5 liters is 1.5 liters, which is the same as 1,500 milliliters. Okay? All right, now let's go to the next one. Okay. Okay, an order calls for 600 milliliters of a 25 milligram per milliliter solution. Okay, so you have 100 milligrams per milliliter stock solution on hand. How many milliliters of the stock solution um, and how many of the mils of the stock solution and how many mils of the diluent are needed. Okay, so let's see. Can we do V1 C1 equals V2 C2? Well, let's see. We have we have 600 mils, so we have one volume. We have two concentrations, so we can find one of the volumes. Okay, so Okay, so we can say, okay, so the total volume is 600 mils, and we have, let me see, 600 mils of a 25. Okay, so that would be 25 milligrams per mil. Okay, so we have 600 mils of a 25 milligram per mil, and then we have V2, and that would be 100 milligrams per mil. Okay, so whatever V2 is, whatever we figure out V2, V2 is going to be the quantity of this one, okay, of this stock solution on hand. Okay, and then V1, we could figure that out by subtracting the total volume from V2. So we'll do one thing at a time. What we're going to do is first we'll figure out V2. V2 is 600 times 25 over 100, and that is 150 mils of stock solution. Okay, so we know that there's of this one here, the 100 milligrams per mil, we have 150 milliliters of this one. Okay, and then if we want V1, the diluent equals 600, which is the total volume, minus 150, and that equals 450 of the diluent. Um, okay, and um, if you add those up, you get 600. And now if we want to do the alligation to see how that matches up with the top equation, and we just okay, we say, well, first we have to do is we have to convert the concentration, the 25 milligrams per mil, and the 100 milligrams per mil. To use alligation, we have to convert those to percentages. Percentages would be, when we're talking percentage, we're talking, okay, we're talking grams per 100 mils, right? So that's what percentage, that's weight per volume, okay? So what we do is, when we have 25, hold on. So, okay, so when we have 25 milligrams per mil, per mil. If we multiply by 100, both sides, remember, when you have an equation, if you multiply the top and the bottom by the same number, it's still the same number, because 100 divided by 100 is 1. So that would be equal to 2,500 milligrams per 100 mils. And milligram is how many grams? Well, 1 gram is 1,000 milligrams, just like 1 liter is 1,000 milliliters. So if 1 gram equals 1,000 milligrams, that means that percentage would be 2.5. So that would be 2.5%, because you say 1, 2, 3. You move it over this way because 1,000 milligrams is 1 gram. So the percentage of this would be 2.5%. Okay. You can also do it like, you could say, well, milligrams. You can do I'm sorry, 1,000 milligrams is 1 gram. You can cross off milligrams. and then 2,500 divided by 1,000 is 2.5%. So 2.5% of that. And then you do the same thing with 100 milligrams per mil, and that's going to be, so if we have 100 milligrams per mil, if I multiply by 100, top and bottom, then that would be equal to, okay, that would grams, oh, that's milligrams per 100 mils. And so that would be 1, 2, 3, that's 10%, right? Because you move the decimal point 3 places over. 1, 2, 3, 1, 2, 3. So it's 10%. So when it's 10%, now what we do is we know that part of it is the diluent, by the way, is the water. So that's 0. And then the top part is we have 100 milligrams per mil, which is 10%. We have the final concentration is 25 milligrams per mil, which is 2.5%. The difference is 2.5. The difference with this is 7.5. The total is 10. So if we want to know the 10, so that's 2.5 parts of 10%, 7.5, excuse me, 7.5 parts of water, 10 parts of 2.5%. So if I have 10%, if I wanted to find out 10%, how much of that is there, then I say 2.5 divided by 10 times 600. It gives us 150 mils. Water would be 7.5 over 10 multiplied by 600, and that's 450 of the water. Okay, so exactly the same numbers that we get in both ways. So we can use this equation, and we can find the same numbers. Okay. Okay. All right. Now now I'm going to go through the problems that you find in the textbook. Okay. So these are the problems from the book. Okay. Problems from the book. Okay. You have 600 mils of a 1.8% sodium chloride solution. And you want to know how many milliliters of water is needed to make it 0.9% sodium chloride solution. Okay, so we're going to first pay attention to see whether C1V1 equals C2V2. Okay, can we use that? Yeah, we could use it, but you just have to make sure you know what what the variables mean, what the V1, V2. So if you have, okay, well, let's go through this here. First concentration, we have 1.8%, and then we know that because we want 600 mils of a 1.8%, so those go together because those are final volumes, right? So we want uh, you have well, actually those are not because let me show you. It's 1.8% of a 600 milliliters solution. But what we want to know is how many mils of water is needed to make it zero point 0.9. So um, this would be okay, 0.9, right? 0.9%. And how many mils of water is needed to make it zero point 0.9 solution? Okay, so that's V2. So now we calculate for V2, which is 1.8 over 600 over zero point 0.9. Okay, and that would be 1200 mils. Now, let's not confuse what 1200 mils means. So 1200 mils is really not the amount of water that you're adding. 1200 mils, if you look at this, remember V2, okay, is right next to zero point 0.9. That means that 1200 mils is the amount of 0.9%. And 0.9% is the total volume. Um, it's not the 600 mils, it's the total volume of the entire 600 mils plus the water. So this is the total quantity of everything. So if we want, um, yeah. So I mean, V1. Let's see, V1 would be. Hold on. You have 600 mils of a 1. So all we know is that we have 600 mils of the 1.8%. We don't, and now we know that there's total quantity of of 1200 mils. So that means that V2 would be 1200 minus 600, which is 600 mils. Okay, so it should be 600 mils. So let's find out. Let's look at alligation. So alligation, we know that there's 0 because it's water. We know the top part is 1.8% because that's what they have on hand. And then we know the final concentration is 0.9%. And we know that the difference here is 0.9. The difference here is 0.9. We know that the total is 1.8. So it's 9 parts of 1.8%. I'm sorry, 0.9 of 1.8%, zero point 0.9 of the water, 0%, and the total is 1.8%. So if we want okay, so we want the amount of the 1.8%, we just say 0.9 over 1.8, and we multiply it by the uh, the total volume, which is, let me see, yeah, total volume, and that would be 600 mils. And then the water would be 0.9, 1.8, 1200 equals 600 mils. Okay, so when you look at the problem, we see that there's 600 mils of a 1.8%, but we don't know how much is the total volume yet. Okay, so if we know, if we put this in here, we see that the final concentration of 0.9% is 1200 mils, then that's the total quantity. So actually, the V we could figure out um, V1 and V2, and we know that it should be 600 milliliters. So we have when we do the alligation and we put in the total quantity, and you can also do it like this. So if you have this makes it actually let's take away the 1200. Let's say we don't even know it's 1200. Let's say we have no idea it's 1200. And we want to find how much. We want to find how much water there is. Okay. So we know that there's 600 mils of 1.8%, right? We know the 600 mils and we don't know X. We don't know how much water. So all you have to do is, hold on, let me try to get some space here so I can show you. Okay, so all you have to do, if you know the volume of one, but you don't know the volume of the other, okay, that's okay. So we know that there's 600 mils of the 1.8%. So what we do, and we know that it's 0.9 parts. So if I said, okay, so 0.9 parts, okay, over 600 equals the parts on the bottom, which is also 0.9, 0.9 over x. Now, if we know that x, so x 0.9x equals 600 times 0.9. Okay, so x equals this divided by 0.9, right? So now we just, when we just solve for x, well, you can see that 0.9 just crosses out, right? And that's what we're left with 600. So we do know that 600 milliliters is right here. All you have to do, if just right next to the percentage, we know there's 600 mils. And these are ratios, 0.9, 0.9. These are parts. You can use them as ratios to calculate anything. That's, you put here, it's 600 mils here. We don't know X. So we just say, well, then we're going to find out what that is. We just say 0.9 over 600 equals 0.9 over X. And X, we solve for X, and we see that X is 600 mils. So it checks out. So now we do know that the total quantity is 1200. And now we do know that 600 mils of each. Well, 600 of the 1.8 and 600 of the 0.9 percent to give you um, the total quantity, 600 mils. I mean 1200 mils of 0.9%. So, okay. Okay, let's do another one. Okay, there is 500 mils of a 1.6% sodium chloride solution. How many mils of water Um, make to make 0.9% sodium chloride solution. Okay, so let's do C1V1 equals C2V2. So there's 500 mils of a 1.6%, and so there's 500 mils. And how much do you need to make 0.9%? And we calculate that. So it's how much, and so this V2 is going to be how much of the 0.9%. So V2, when you calculate for V2, it's 889 milliliters. Now remember, the 0.9%, how much do you need to make 0.9% sodium chloride? So this is how much 0.9 there is, and since this is the total, um, the the total volume of 0.9%, this is the total volume, okay, of the 0.9% of the total volume of the product when you mix everything together. Okay, so how much of each is going to be in there? Well, we can do that with alligation. We can also do it with let me see. So it's total. There's 500 mils of 1%. Okay, so let's do alligation and let's find out total quantities of each. So we have water, right? So we know water is 0. And then we know that the top part is 1.6%, okay? And we know that the final is 0.9%. Okay, so that would be the difference is 0.9, the difference over here is 0.7, the total is 1.6. Okay, now we know that there's 500 mils right here, 500 mils of the 1.6%, but we don't know how much is this one, right? So now all we have to do to find out this X number is say, okay, well, we know that there's zero point 0.9 parts of 1.6%. And well, let's see here. So there's point, well, okay, so 0.9, okay, zero point 0.9 parts over 1.6 equals 0.7 over X. Because we know this one over this one is equal to this one over this one. These are all ratios. You can set them equal to each other, and you'll find out X. So then, if I figure out X, so that's 0.7. Okay, so that would be 0.9x equals 0.7 times 1.6. So X equals, let me just do my trusty calculation here. 1.6 times 0.7 divided by 0.9. Okay. Okay, so that would be 0.76. Okay, So that would be, wait, what did I do here? I said 0.9. Oh, I'm sorry. You know what I did? It's 0.9 over 500. I don't know why I did 1.6. It's 0.9 over 500. And that equals zero point 0.7 over x. That's it. So 0.9 over 500 and then equals 0.7 over x. Okay. Now that means that x should equal, let's see, that would be 0.7 times 500 divided by 0.9. Okay, so that's so x equals 389 mils. Okay, and then if you want, so now we know that x right here is 389. If we add up, let's see, so the total quantity, 389 plus 500, 888. So total quantity, if you mix, okay, so 500 plus 389, we get 889 milliliters. And it checks out because right here is 889. So you notice how this is the total quantity. I mean, I'm sorry, the total volume. The total volume of what is here, okay? Because V2 is right next to zero point 0.9, and zero point 0.9 is the total final volume, or the kind of total final percentage. Okay, so it's going to be, the total will be 889 mils of 0.9%, which would be, which is 500 mils of 1.6% and 389 mils of water. Okay, we're going to go through one last problem. How many mils of 70% and 40% solution should be mixed to prepare a 400 mils of a 40% solution. Solution. So we first, okay, how many mils are 70% and 40% should be mixed with 400 mils of a 40% solution? So, okay. All right, so we have the bottom is 40%, the top is 70%, because the higher concentration goes on the top, lower concentration goes on the bottom. The final is to prepare of a 40% solution. So this is, okay, so that's 0, right? Because the difference between 40 and 40 is 0. The difference between 70 and 40 is 30. The total parts is 30. So there's 0 parts of 70%. So there is no 70% that's mixed. And there's 30 parts of 40%. The total is 30. So, and we know that 400 mils of a 40%. So we know that there's 400 mils. So what we do is we say for the 70%, it's 0 over 30 times 400. Well, we know that 0 over 30 is 0, so that's 0. And we know that anyway because of this. So we know that's 0. And then for 40%, there's 30 over 30, which we know is 1. And that's 400 mils. So we know it's 1 times 400 mils, which is equal to 400 mils. So that means that there's no 70%, and there's 400 mils of the 40%. So there's going to be 400 mils of 40% and 0 mils of 70% to get you 40%. Okay, so because it's I mean, intuitively speaking, you can't mix 70% and 40% of something to get 40% because you're mixing 70% is higher than 40. If you mixed if you've mixed some of the 70%, then you have to get higher than 40%, right? You can't mix two higher concentration and the same concentration and get 40%, right? That makes just no sense. So 70% is nothing, and 40% is all of it. That's 400 mils of 40%. Okay? All right, and I think that should do it. I think, I'm sorry, I have one left that I didn't cover. Um, so you know what? There's one left, actually. Let me just do that real quick. Okay. Okay. If you have 250 mils of a 3% sodium chloride solution, how many mils of water do you need to make it a 0.9% sodium chloride solution? Okay, so we do again the C1, V1 equals C2, V2. Let's see, so there's 250 mils of a 3%. And then the final concentration is the 0.9%. And we know that V2 is the amount of the 0.9%. So V2 is 833. V2, so V2 equals 833 milliliters. So that's the total final value because this is 0.9%. Okay, so if now we do So we know that this is the final volume V2, okay, of the 0.9%. So if we do the alligation method, we have 0 is water, 3%, and then the final is 0.9%, which means zero point 0.9 is the difference, 2.1 is the difference. So in the total parts is 3. So we know that 3%, we know that we have 250 mils of 3%. Okay, why don't you pause it and then try to figure this out. What is this here, X? How would you do that? Go ahead and pause it. Okay, now, if we know that we have 250 mils, we know that quantity, but we don't know how much is down here, how much water. How many mils of water? We do have no idea. So what we do is we say, okay, we know that 0.9 over 250 equals 2.1 over x, which means that x will equal, let's see, that's 583. 583 mils. So the water is 583 mils. So right here, we know that there's 583 mils of water, 250 mils of the sodium chloride solution, the 3%. If you add these together, you have 250 plus 583. You should get 833. 250 plus 583 is 833 mils. And it checks out. Okay, so don't forget what this means. The V2, if it says 0.9%, and we know the 0.9 is the final concentration, that's the final concentration, then we know that that's the total volume. That's not the volume of water added, that's the total volume of the whole solution, and that's 833 mils. And we know that from the problem, we know 250 mils is the 3% sodium chloride solution. All we do is, since these parts, these ratios, you can just divide whatever quantity here, whatever volume here. So we have 0.9 over 250 equals 2.1 over x. And that gives us 583. You add 250 plus 583, and then you get 833 mils total. Checks out perfectly with the C1V1 equals C2V2. Okay. Okay. Thank you, and until next module.